So try to run away as fast as possible.
Wait, what? You have to spill on somebody's book?
Yes, we all know I'm going to spill water. Okay, so we know that Andrea's pipe and my pipe are pretty well the same pitch, right? So if I heat up, also I've got these two that are about the same pitch. So if I heat these pipes up, not my computer, and then who wants to play the hot pipe and who wants to play the cold pipe?
Can I play a cold pipe?
I'll play the hot one.
I'll play my normal pipe. Okay. Alright.
My shirt.
I don't want to play burning hot.
I know, that does not sound very fun.
Alright, so you play room temperature pipe.
What if your like
No,
lips
that
get
was
stuck
mine.
to it?
My lips have been on it. This one.
It's okay.
So play room temperature pipes. Stephanie, do you want to play
I'm sorry,
cold
that
pipe?
sounded really demanding.
My lips were on that.
Christina wanted to do that.
Christina. Alright, try to make a noise out of it.
That's like,
Alright, Andrea, you make your noise.
It's
Show me
cold.
first. Yeah. As your fingers freeze, you...
just like this.
Ooh.
So again,
Alright, your long pipe.
Wait, can I get like a
Medium.
boiling hot one?
Sure. Put your hand in your sleeve.
Oh really? I can't
They're
have
the
one?
exact same.
Will it burn my hand?
This is Matthias.
Or will it mess up my shirt?
Is yours cold?
No, it's room temperature.
Low across the
Mine's room
pipe.
temperature.
Alright, so
Do I
Stephanie's
touch
ours
it?
are the
Yes. Do I
same.
have to touch the bottom?
Just
Ours are the
same, Mrs.
Yeah,
Matthias.
covered up. Yeah.
Ours are exactly the same. Are they different temperatures?
Yeah, mine's
Totally
cold.
that hot.
Let's see.
it's hot up
Bummer.
there.
Let's
See,
see.
I told you.
Here, alright, you play.
Higher pitch canceled
Dude,
out.
that is
and
You play
it's the
yours.
same.
It's a little lower.
That's your whole thing.
Okay. So listen, my cold pipe and Andrea's normal pipe.
He plays the piano.
So what, is mine lower or higher than hers?
Yours is lower.
My cold pipe is lower than Andrea's normal
Aha!
pipe.
I was right. The lizard does get slower.
I got it. See? Boom, paid off.
Ready?
Just
All
keep
right.
Hang on,
going.
play
Now,
it.
Josh, what do you have? Oh. So, what is
Wait,
this?
is that really
that
the cold
hot.
one?
This is cold.
Oh, that
This
is.
is
Oh,
really
that is really cold.
Alright, so Matt's pipe is definitely
Now our
higher
hands
than
smell
my
like
pipe.
metal.
Warmer's higher.
It's not that cold.
Do you want me to fish it out for you? It's
So-
hot.
Ms. Matthias, what was our hypothesis for why it got
That's the
hotter?
side. Hold on, I'll show you.
What?
You have to. So his is higher.
That is so funny. No.
Is it warmer? His hot pipe is higher than my normal pipe.
I could have used one of these this weekend.
What? That was really
Camping.
weird. Oh, camping.
Okay,
That
so
What did you do this weekend?
tell me that video is running, right?
What? Yes, it's
Hi, can you
running.
see me?
Sorry, Mrs. Colby.
Sorry.
Josh,
So-
What? That
Alright, have a
was.
seat.
You guys. Oh,
Oh,
Don't
wow.
You're making him do. He's gonna get dizzy now.
Okay,
I'm
listen.
sorry.
So
Sam.
what we observed is that the cold pipe has a lower pitch
Look, you
than
messed
the
up.
normal pipe, and the hot pipe has a higher pitch than the normal pipe. It's
I
really
was
hard to
credited
make that
in-
observation.
Okay, try this. These are ones.
But
What was our hypothesis as to why the pipe that was hot got higher?
okay, the pipe that's hot. Well, here. So let's look. Which one of these was right? Okay.
The first
the
one.
cold
The lizard.
things.
The lizard.
Right. Slowed. So the air in the cold pipe is actually going to move slower, right? Less kinetic energy in the air molecules, moving slower. Okay, air that's moving slower is going to have a lower frequency, lower pitch. Okay, the pipe didn't shrink enough to make a difference. So why would something that's hot have a higher pitch?
Because the hot air moves faster.
So hot air has higher energy, higher frequency, because sound travels faster in hot air, and so
Stop
higher
doing that.
pitch,
Why does it make this noise?
because it's how it oscillates the air.
But I mean, I'm just pulling my finger out.
Stop.
So,
Break your finger.
No.
let me see.
No,
Is your-
that's kindergarten.
What sort of temperature do you have right now?
32 degrees Fahrenheit.
Not me, definitely.
It's warm, still warm. Let me see. Oh.
I can't smell anything.
Alright, so here's a warm pipe,
Dun, 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 dun.
and here's a cold pipe.
We're almost the same.
We've been out a while, so.
They
Yeah.
sound identical.
What if you like?
Shut up, monkey!
Dude, stop.
Get out
Don't
of
make
here.
it like.
Which one?
This is hot. Colder's lower.
Gosh, no.
Hot's higher.
Mm-hmm.
Alright. Well, there, they'll all get washed.
So
Okay.
smart.
So that was an enjoyable experiment. So now you're just gonna write a brief discussion about why, and like read the book and really tell me why hot air would oscillate differently than cold air and how that changes the
So what's
pitch.
the objective?
Do a good job. No objective, just a discussion.
So that's all you have to write?
Yes, just a discussion.
What,
Oh,
what
then
are
you're-
we trying to
what
tell
would
you
your
why
objective
hot
be?
air oscillate?
Why does hot air oscillate with a higher frequency? Yeah, if you're using the same length of pipe. Okay, so what would your objective be if you wrote one?
To observe
And explain.
and explain why hot,
Differences in
why
frequency of
air,
something.
no.
The
How
effect of temperature on
frequency.
in similar substances.
The mathematical proportion of difference in frequency
Ah.
at different temperatures.
I stopped listening now.
Okay.
Okay, so- Let's see. Let's start with review questions and talk about those. Make sure we've covered everything halfway decently. Next week we have a lot of options of things we can do. So the more we cover right now, the better fun we have next week. All right. So where's the review questions? Grab your review questions. First one says, Josh. Nick.
Josh.
What is the difference between a transverse wave and a longitudinal wave?
This is the electric from?
First
Number
review
one.
question.
The transversal wave is perpendicular
baby
to
split
oscillation
example.
and like
The oscillation is perpendicular to
Effective advancement.
oscillation is perpendicular to direction of travel or propagation. Okay. And how about in
Longitudinal?
yeah, that.
it's parallel, it's not perpendicular.
Okay. So it oscillates in the same direction it travels for a longitudinal wave. Okay. And which one best represents light?
The one where
Transversal?
you
Transverse. And how about sound?
longitudinal.
Okay, there we go. Two sounds of equal pitch are heard. The first is quiet and the second is loud. What are the frequencies?
They're equal.
Right, if they're the same pitch, they're the same frequency. And the amplitudes?
They're
The first has a
lower
smaller amplitude than the
The
second.
louder one is bigger.
Josh, what were you gonna say?
lower amplitude
I was about
wave.
to say lower
Is what?
altitude.
Huh?
The first one is a lower amplitude, smaller amplitude?
Yeah.
Okay, quiet is a small amplitude, loud is a big amplitude. And their wavelengths.
Are the same.
Right, because frequency and wavelength
The same thing.
are, yeah, well, they're not exactly
Oh,
the same
close.
thing, but they depend on a constant between them, the velocity, so
Do you
they.
like that monkey, Josh?
Who's your-
Number 3, Suppose a man is in a car stopped at a stoplight. Another car starts accelerating away from his car, blowing the horn. As the other car accelerates, what will happen to the pitch of the horn heard by the man?
It will decrease.
It will decrease. Why?
Because the sound's going further away.
Okay, and as sound gets further away, what happens?
It gets lower.
It gets stretched out.
So this is always hard for me to picture. Okay, so we got stationary guy here, we got guy moving this way here, right? So when he's here, let's say that's his sound wave when he's still, right? Then when he starts moving away, what will his sound waves do?
Spread out.
Spread out, and sound waves that are more spread out have what kind of frequency?
The lower frequency.
Lower frequency, and lower frequency means
Lower pitch.
lower pitch. So that's kind of how I picture it, is a constant pitch here. As it moves away, in relation to you, it seems like it's spreading out. So the pitch will go down. If you look at the equation here, the frequency that you observe, if the sound is moving away from the observer, then you have a plus sign in the denominator. A plus sign in the denominator is going to make that number shrink, right?
Mm-hmm.
So frequency is going to go down, that means pitch is going to go down. I would definitely recommend memorizing this equation and understanding it, or at least if you can't totally understand it, memorizing what
we
to
have to
do.
memorize
Yeah.
So it tells.
That's how the GPS works. Like
Is it?
they have like all the satellites up there, and they use the Doppler effect. So like they can tell when the satellite passes right over it because the pitch of the signals change.
Yeah.
And so they have like a dozen satellites that it's all getting information from, and they can tell where all the
I hate GPS.
Cars
just
or
like the
stuff.
Those things are so
the
annoying.
lines
The lady
to
on
the
the
one
one's
spot,
car.
and that's where
You
you
can
find
turn
Turn
the
the
volume
sound
down.
off.
Turn
I
the sound
tried,
off.
and I don't know how to do it.
Somebody go turn his sound off after class, please.
Then how do you
Sound off
get
for what?
places?
Turn
Off
off
your
your phone.
GPS.
Oh yeah.
I just have the sound off, so I have to read it.
Oh, you do. Well, you know you can like get different voices.
I've heard that.
Yes,
I've
you
heard
don't
like
have
a
to listen
British
to the British
accent
lady all
lady.
the time.
Oh, I put it in Spanish and see if I can learn Spanish while I drive.
Yeah, that's a good way to wreck.
What are you saying? What?
What was that?
Hola, ¿cómo estás? No.
Alright, number
You
2.
crash into a tree.
Wait, we already did number 2
Number
and number 3. Yay for us. Number 4, a stationary siren. So it's holding still. It emits a sound wave with a frequency of 511 hertz. If you hear it with a higher frequency than that, are you moving toward it or away from it?
Towards it.
Toward it. So we've got our stationary siren. As we move toward it, that sound that's, coming out of it would get bunched up even tighter than it ought to be because it's adding to our motion. So we're going to hear a higher pitch. So higher frequency makes sense if we're traveling toward it. Is anyone still stuck on that at all?
No.
All good? Okay. Name at least 2 differences between sound waves and light waves.
I thought we
We only did
four.
4.
I bet you can do it. What's the
Two
difference?
A
differences,
sound wave looks like a slinky. A light wave looks like a water wave.
and it's made out
Okay.
of particles.
Light waves may
A
or
light
may
wave
not
looks
be
like
made
a
out of
monkey.
particles at any given moment.
Making it
And-
faster.
You can see
Okay,
most
light's
you can't see
faster.
sound.
What?
You can see some light, you can't see any sound.
Can see some light,
You can
can't
feel
see
it.
any sound.
You can
Wow.
see
Can
the
you
effects
feel
of
it?
You do.
sound.
No.
Yes.
No.
Or
No,
heat.
you could
from the
That's
light.
not-
Well, that's the heat, not the wave.
Well, heat is a form of electromagnetic.
Oh, so I'm right. That's
Oh,
not,
yeah, you're doing
that's
sound
not
waves.
different.
You can confirm those and things.
Yeah, the sound
Like the
vibrates.
Mhm.
Especially if you're at a concert, you can feel
Yeah.
it.
Yeah.
Yeah,
Your
that's
heart's
what
gonna
you're
like
talking about, yeah.
explode.
Does
Like-
light need a medium through which to travel?
Well,
No.
It
Why?
goes through
How do you know?
air.
Space, there's nothing.
Maybe yes.
but-
Light can travel through space where there's no medium. Space is pretty well empty.
You can't really have light travel through it, like.
But wait,
Log.
there's
And
a
God created
definition.
light,
If
and
light
there
is a
wasn't
But
a
it
wave,
can
medium.
pass through
It's
some
just
solids
light.
though.
Like what?
Like glass.
steel.
Oh.
I mean,
Steel?
Wait, no, we're
it's
talking about.
passing through.
Oh, we're talking about
I was thinking
sound.
like-
or
I was
light.
thinking
I thought we were
air.
talking about sound.
Can sound travel through space when there's no medium at all?
No,
No.
but the definition of wave
That's
is
sad.
What if
something
you-
that goes through a medium. So if light is a wave, how is it going through space?
Because it's a particle.
Particle.
Oh yeah.
It's
So
like- it's like particles
going
and
through
waves.
space and it hits the atmosphere.
It's like-
But
That's
how
not
do particles
exactly it.
move if the wave can't? It's a particle wave.
What?
It goes in a straight line. That's why it's faster in space when it's not going through medium. Then when it hits the atmosphere, it gets back into wave.
Now this
Why
is
would
something
you
that
be
you want
on
to know for the
Mars?
test.
Like,
You definitely want to
you're
understand
not supposed
how
to
light
walk on
and
it.
sound
It's
travel through things that are more dense or more compressible. So make sure I talk about that in a minute. Okay, so we keep talking about the wave-particle duality of light. Just means that light behaves as a wave in some situations and as a particle in other situations. If it is a particle, as far as we can tell, it doesn't have any mass. People think that there's another particle, the gravitron, that doesn't have any mass, but causes gravity.
Wait, what?
The thing
Yeah.
at the fair.
I
No.
never go to fairs.
Good, because those things are the same exact rides that I rode when I was 9. I'm not even kidding.
Oh, the
And
fair
they lose,
rides?
they lose
Those are-
bolts each time they put them up. And
Yes,
go back.
they do. You do
They
not want to
lose
get on those
bolts.
things. They
Well, they don't
the
know where to
maintenance
put
on
them.
those is so dangerous. You just don't want to get on a fair ride.
They're fun. Some of them.
Those even those
I
like
read the
Those
Ferris
gravity
wheels
trams
or
will get you
whatever,
in
those
there,
can
though.
like break easily too.
Can you
I
imagine
got
like
stuck
They
in a
always
broken
stall
Ferris
when I'm
wheel
on
at
them.
the top for like,
No, you didn't.
oh yes, it was.
Same
I bet
thing
you were
happened to me when I was
Did
I
like
mean,
you
I
start
was right
falling
set
out?
up. I was little, but my mom was with me and she was more scared than I was, so I stayed calm.
Same thing happened with me and my dad. I was like 5 years old at the very top of it.
Oh, that would have been
Oh,
scary.
I was
so
on
a
the
5-year-old
I was
boy
on the
could totally
Griffin
fall
at Busch
out.
Gardens.
It's
You know how
really
it
big,
hangs
so-
off the side? It
There you
stopped
go.
for it stopped for 10 seconds. I was so
In
scared.
Florida or?
No,
Here.
Maryland. You
That's
know where it's
right.
supposed to
What
stay
ride?
for like 3 seconds and then drop?
Yeah.
It stayed for like 10.
Maybe it just felt too long.
There's one, like,
No, it was
Florida called the
they.
Ship
No, I
Ride.
asked them too, and they said it stayed longer than it was supposed to.
Because it was
And it like breaks off.
No.
Right, it's too scary.
Die.
God save me!
Okay. Time to share the gospel with your neighbor.
You're about to die in 10 seconds.
Can you share the gospel in 10 seconds? I took a class on that once. How to share the gospel
Jesus died
with
for your sins,
checker
believe in it.
at the
Bye.
grocery store.
That'd be
Yeah. It's like how to teach chemistry in 90 minutes.
Uh,
Not possible. Okay, so number 6, light behaves as a wave in some situations and particle in others. So what's one situation where light behaves as a wave?
when it flies. Or
When it
so-
goes
Doesn't-
when
through
it
something.
flies.
when it goes through a little hole.
Okay, well,
That
And
guy's
then-
experiment.
like Young's experiment, where you see wave interference patterns, right?
Tongue just got tied.
So it does have interference like a wave. Also, it refracts like a wave. We'll look at that next week. We'll pass light through glass or something.
Or
Hopefully, I
water.
can find my thing.
No, we can get a
I'm not
magnifying
saying
glass
I was giving
and burn ants.
Well, like you know,
Talk about-
no.
Or-
When you stand in the
or-
pool, you know that it looks like your legs aren't in the right place
Right.
because light
I feel like I
refracts
got
through a
really
medium
excited and I couldn't find
density
it.
change.
or you're looking at someone out of the water.
Basically, yes.
Maybe it's the week after next, but anyhow.
Yeah, like you're underwater and you're looking at
How
something.
about how does light behave as a particle?
It travels through space.
It
Okay.
waves like
Yeah.
It travels without a medium. Light doesn't necessarily need a medium to travel, so I'm not 100% sure that that's exactly it. But the photoelectric effect, which you haven't read about yet, but I might possibly try to explain to you in a few minutes.
Oh, is that the thing where like they turn on the light and like photons start coming out of the metal or something?
Electrons come off the metal, so.
Yeah. I just saw like a sentence when I put the head accident. I just
Mhm.
was.
Right, so,
Somebody dropped a bunch of glass or something.
I like the glass.
okay. So, number 7, this is pretty
We
easy.
only went to number 4.
You did this in chemistry though. If light wave A has a longer wavelength than B, then which has the higher frequency? So what's my equation?
B, I think.
F equals.
It's
V
more
over
than
lambda.
passing through, right?
So if it says it has a longer wavelength, then what happens to its
It
frequency?
gets
It's
smaller.
smaller.
Okay, so longer wavelength is higher or lower frequency because they're inversely proportional,
Mhm.
right? They have a constant that relates them in an inverse way. So which one, what's the answer? Which one has the higher frequency?
The one with the shorter wavelength.
Yes. Higher frequency is shorter wavelength, and that is B. So, and you definitely want to give me an equation and tell me that they're inversely related in your answer.
What if we just give you the equation with the arrows?
And I'm going to draw a brownie face. And
So I-
possibly take off a quarter
I
point or
entered on the
something.
test.
I have 3
Right.
points taken off this test for me.
Yeah,
I
I
just,
never
Did
put
I take
inverse.
off-
I
in there.
always
keep
forget
telling
to
you
put
I'm
the,
gonna.
like I
You did
keep,
I
I
always
always
see the
want to put the
arrows.
I got
equation,
15 off 15.
but then I always just
Oh, look at this.
don't
That could be
remember.
a problem.
That is so.
I know the equation.
I know.
I
Joshy!
remember 8.
What?
In the question
You're
above,
gonna
which
break
light
it.
wave
What did
has
you do to
more
it?
It's
energy?
moving, see?
That's pretty cool.
You make it move. No,
What
it's
is,
not.
what is the thing?
It'll make it move.
That's pretty cool.
Fun.
It's a new wave.
I know. If only I knew
smart.
what that was.
It's
Maybe
like
just-
a loop de loop.
Would you guys not know what it was or
The
something?
loop.
We couldn't tell if it was
Tangle.
how it was stuck or whatever.
Yeah.
All
Hey,
right.
can I have it back so I can fix it?
So also you
Whoa,
learned
dude.
this in
How'd you do that?
chemistry.
I told you it's fixed. It's magic. I know magic tricks.
All right.
Harry
E equals
Potter.
HF. Energy
Wait, I hate
is
him.
directly proportion to frequency
I'm
with
afraid
Planck's
your test
constant
wrong.
H in the middle
Oh,
there.
that's true.
So here's the equation. In number 8, Josh, which light wave has more energy? So if you want to know, Josh, look at me. If you want to know which one has more energy, then would it need to have a higher frequency or lower
Higher.
frequency? Higher frequency has higher energy because they're directly proportional. So whichever one had a higher frequency, that would be which one? B. So B also has the higher energy because higher frequency has higher energy.
Is H set 6.67 and 10 to the 19?
Oh.
Or 10 to negative
Negative
11?
19, I think.
I think it was negative 11.
Oh man, I messed it up.
Oh, in chemistry, but they're going to give you different units for Planck's constant in physics, so you can use electron volts instead of, I don't even know, what was it? Like,
It was like something weird, like kilogram squared per meter squared per second cubed or something. Or something
yeah,
really
different
weird.
units for physics, but you could just convert everything and use Planck's constant like you used it in chemistry.
Okay.
It's the same. Okay. So now it's time for me to explain the photoelectric effect in some way that makes sense. So let's go.
Wait, are we not doing practice problem?
It hurts
We will
worse than
eventually,
that.
probably. But
That's what happened.
before you read this, I just want to have a go at it. I'll repeat myself again next week because it's just complicated. But I don't know anybody who read this for the first time and went, oh, that's obvious. So before you read it, let's have a go. Okay. So in the photoelectric effect, you have a sheet of metal, okay? You shine light of a certain frequency on it, and depending on if you have the right frequency, electrons are liberated. And it happens almost instantaneously. Like, bam, you shine the light on there, and electrons fly off the metal. Now, we all know that metals like to donate electrons anyway. They're willing to lose electrons. But it takes energy to remove those electrons, right? So, we know light is energy. We know that when we shine it on there, the electrons are liberated. But we don't know of any other waves, Josh, that
It didn't break.
that actually crash into something and cause a particle to move, right? I mean,
Is that because light is energy?
well, it's because light is a particle.
I mean, it looked like it was.
Also, the intensity of the light has no effect. Okay, you can shine very intense bright light of certain frequency, or you can shine a dimmer light, but it still happens. The photoelectric effect does not depend on the intensity of the light. Electrons are liberated no matter how intense the light is.
Talking about light, they said that if the sun stopped, like just randomly stopped giving off light and heat, that we wouldn't be able to tell it for like
8 minutes.
yeah.
Because light has to
Does
travel,
it travel?
and it travels, it takes about 8 minutes to get from the sun.
And then we'd all die.
That's pretty cool.
Well, they probably know
Well,
because
we
I'm
had
sure
8
there's
minutes to
something
live.
monitoring the
No,
sun.
really, you have to wait
Yeah,
for the
you
light to
have-
get here to see.
You
We're
really
seeing an
can see
8 minute
it.
delay from the sun and a 1,000-year delay from probably the next.
There's
closest star.
nothing in space that's monitoring the sun.
What?
There's nothing in space that's monitoring the sun. Like,
Well,
to
there
make sure
is.
it's still going.
yeah.
There-
Pretty sure
Just
it's
an
gonna
8-minute
stay
delay.
Yeah, so you would realize what happened as soon as.
I don't know. There's
at the same time
superstitious
as
people
your
out
light
there.
disappeared.
You couldn't. You,
What if it stops?
there's.
Oh, look,
Turn
the
back
sun
on real quick? It's
stopped.
like burst of
Whoa.
cold air.
Let's jump it
Darkness,
with our
you
jumper
know.
gables.
Nope, it would be too late then.
I wonder what
Although, I mean,
like-
the sun would have to undergo
to
some kind of implosion or
on
explosion.
itself.
So you'd probably disappear before the light stops.
Yeah,
because you'd
we
be
wouldn't really
exploding.
notice.
Like suddenly we'd just be gone.
Gone.
It's like that one movie that we saw together.
But you know,
It's
someday
horrible.
suddenly we are
Not
going to be
knowing.
gone. That is a reality.
When
So,
you
that it?
die.
Yeah.
well, Jesus
When
will come
he's
back.
like,
or,
Oh yeah.
Or we'll
Here
die.
comes the sun,
But,
and I'm
I
gonna
mean,
Sure,
die.
nothing's first.
gonna
And
come
then let's
that
go
fast.
fall like with these two
And I
random
think it's gonna be
children.
So
They run
good.
out.
Or get ready.
Or you can get one of those little shriek ray things, like Despicable Me or whatever it was. and
All right,
then-
hold tight
okay,
here.
all
Hold
right.
tight. Now listen. This is important and complicated. Okay.
But then
Um,
we'd still die.
If the light is more intense or less intense, the photoelectric effect still happens. But more intense light will make the piece of metal give off more electrons. Okay? But it still happens no matter what, as long as you're in the right frequency range. Okay? Every metal, each individual metal, whether it's copper or, lead or whatever you're using, has a characteristic frequency limit where the photoelectric effect stops working. And that's unique to each metal. Light below that frequency means that no electrons are emitted when that light is shined upon the metal. And then light above that frequency means that electrons will be emitted, and the brighter the light, the more electrons. But it doesn't matter how dim it is, if there's any light, some electrons will be emitted. The kinetic energy of the emitted electrons is directly proportional to the frequency of light. Okay, so the greater the frequency of the light, the greater the kinetic energy of the electrons emitted. Okay, so this indicates that frequency is related to the energy of light, which we already knew. And so people saw the photoelectric effect happening and said, what? It's a wave, how is this happening? So then they had to explain it. So they explain it with photons. Photons are little electromagnetic bundles explained by the E=hf equation. Okay? The hypothesis here, which we don't know necessarily if it's true or not, but it's the best we've got, is that collisions between photons, actual bundles of light that somehow behave as a particle, and the electrons in the metal transfer energy, and so the electrons gain enough energy to be liberated and fly away. And you can do the math, which is very, very accurate to describe reality, to find the work function. So think of metal as holding on to its electrons very tightly. As long as light of a frequency big enough crashes into the metal, those electrons will be liberated. And you can calculate the kinetic energy at which the electrons are liberated with the equation. And you can see like what the maximum kinetic energy of those particles would be. Some of them may have less than that, but it's just really, I mean, it seems to work, so it does seem to indicate that light is a particle, which we would call a photon. But I would hedge my bets and say seems to a lot, because, I don't know, it's pretty complicated, and even more complicated than that. So, that's the point. So I'll let you guys try review question number 10 next week and see what you can make of it after that explanation, and then we'll go over it and I'll explain that again after you've read it and see if it even makes more sense or any sense. But that's like kind of an intro to work function. So let's look at practice problem number 1. What is the speed of sound in air with a temperature of 90 degrees Celsius?
That's a lot.
Oh wait, I want to talk about few more theory things. I just told you guys not to let me forget to tell you. Important things such as, oh wait, I'm supposed to tell you that next week. I'm gonna tell you anyway. Alright. The speed of sound increases as density decreases, usually. And it's,
It looks like bubbles.
No, it looks like that neutron thing.
Oh.
Like
What?
the picture.
It looked like the neutron thing, is what she was saying.
okay, so speed of sound
The
is
electron thing.
inversely related to density. Now, how does this seem counterintuitive? What are you always taught about water? Sound travels.
Faster than water?
Does that appear to be true here?
Um.
Is water denser than air?
Yeah.
Yeah.
Water's denser than air, so should sound travel faster in water?
No.
No.
Why is it like louder sometimes? Like
Well,
you know, like
it does travel faster.
like if you put your
in water.
ear like up against a like
Because it travels
Like a
faster,
board
it
or
gets
something like
juicier,
that?
It doesn't have as much time to fade away.
There's another characteristic that's more important than this rule for sound, okay? The more important characteristic, this doesn't work at all. Nope. Okay. Speed of sound increases as
What are you doing,
compressibility. Decreases. So that's a down arrow, I promise. So
Okay.
is water more compressible than air?
No,
No.
you can't compress it.
Okay, this is the more important fact, okay? Something that is not very compressible will have sound traveling faster. This is why, sound travels faster in water, not because water is more dense, but because it's less compressible. So, just so you understand that if somebody's talking about density, then density actually,
Refers to compressibility.
no, density, an increase in density would decrease the speed of sound, but an increase in compressibility would,
Decrease the sound.
thanks. I can easily make a mistake when I'm talking about those things without really thinking.
It's like,
So,
don't do public math, don't do public
I don't do
physics.
public math. I don't do public math. Public math is bad. Okay,
I went and said 2 plus 2 is 5 once somehow.
I saw a
It's like a
billboard that
little
said 1
boy.
plus 1 equals 3 the other day, but they were talking about decreasing teen pregnancy rates.
You were so.
So, anyhow, off of that topic, for light,
I never seen it.
speed of light in air does not depend on what?
Something that isn't temperature.
It is temperature. Speed of light in air does not depend on temperature. The speed of sound in air,
yes.
And on
Yeah.
temperature.
sound.
There's your difference.
Speed of sound in air does depend on temperature. So that's a good to know little tidbit there. That's all I want for this week. Okay, now we can do a practice problem. Just making sure, because there is a question on the test that's kind of naughty about knowing that stuff. Okay, what is the speed of sound in air with a temperature of 90 degrees Celsius? So I have an equation on the board that might help you out with that.
It would be like 60.6 minus 6.06 plus 331.5.
Okay, so here velocity equals 331.5 plus 0.606 times the temperature in Celsius, which in this case is 0.0 in meters per second, and the Celsius cancels out. And what do you end up getting if you plug that in?
386.
0.0.
Liters per second.
0.0.
0.0.
0.0. My bad.
Now why?
Because you're doing addition, and you have to go to the least. What do you call it?
The place of least
Yeah.
significance. Okay, so here you end up with, when you multiply this, you end up with something to the tenths. when you add, you have significance in the tenths here, significance in the tenths with this thing, so you end up with significance still in the tenths because the rules for adding and subtracting are different than the rules for multiplying and dividing. And you
Should
get to
it
use both.
be- Oh wait, no, cause you round, so, wait, no, wouldn't it still round to 36.4?
Well, if
No.
you do
Was like-
90 times .606.
Says it's 0.04.
It's this, and you get three significant figures, so it'll be 54.4. And then here you would do 331.5 plus
Oh, wait,
54.
okay, yeah, I messed up something.
And you get out to the thing there. But if you let your calculator do it, you don't end up with a 9 here, because you can see this place will round the 9 up.
Okay.
So. But you do get to keep the tenths place, is the point.
Okay.
So, no fun in the problem, but fun in the significance. The frequency of sound is 1,621 hertz. If the temperature is 30 degrees Celsius, what is the wavelength of the sound wave? So,
You have to find the speed.
speed first. So, same equation. And what is the speed?
Someone just knocked.
0.216. Oh wait, no. 3.349.7 meters per second.
Anyone get anything different than that for the velocity? You just do exactly the same as the other problem. 331 plus 0.606 times 30 gives you this. And then how do I find, what do I want? Wavelength.
Frequency equals velocity over wavelength. And we know the frequency when we know the velocity.
And what's the frequency?
1,621.
Unit.
Hertz. Sorry.
Times.
So I'll make that 1 over second.
So,
Because hertz is 1 over second. And the, hold on, I'm doing that wrong. What's the velocity? That.
Yeah.
349.7 divided by 16 what?
1621. 1 over second.
Okay, so my seconds in the denominators cancel, and my wavelength is what?
0.216.
I can't do it big. 216 meters. Okay, so, let's see.
Josh, what's the speed of sound at 0 degrees Celsius?
7.
No,
4.
331.5.
real fast. What?
331.5.
Very
No,
good.
Did
yeah.
you say
Because
sound
you
or light?
multiply it by
It's
0.
sound.
Right.
And add 0.
I
No,
thought you said
0
light.
is significant to the.
What's the speed of light at 0 degrees Celsius?
I have no clue.
Three
That doesn't
point
matter.
10
Turtle.
meters per second.
Yeah.
Turtle.
It's like 2.99 something, but yeah, 3.0 times 10 to the 8th meters per second. And does it matter about temperature?
No.
How?
You just have to have it memorized.
Yes.
Actually,
Actually, your test gives you a conversion factor for nanometers, which you had better learn to use your calculator to do. That. Because I remember your chemistry test last year.
Well, I'm using a better calculator this year.
Good.
Because last year I had this scientific calculator that never did
didn't
anything
even
right.
know how to work.
You always had every problem right and the answer wrong. And I'm like, ugh.
Dude, I can't believe I ended up getting.
And it gives you Planck's
Because of my-
constant.
because of my,
So just like the top of the practice problem, that's all the test gives you. Let's see.
Yeah, I hit a bunch.
All right, so number 3, did we just get the speed? Did we do anything? We haven't done anything. What are we doing? I've lost
Number
track.
3.
I have 4 significant figures in number 3. Why?
We haven't done number 3.
No, number 2, I mean. Why do I have 4 significant figures?
I have 4 too.
Because you're not supposed to.
Oh, I got 4 here and 4 here, so I should have 4.
I watched the marathon. It was going
Well, the temperature is only 30 times 0, so that would limit your
I'm
meters
so
per
excited.
second.
5, 7.
I haven't get
Okay, so 4 significant figures, because you have 4 here and 4 here.
No, But when you use your equation to get your meters per second, your temperature was 30.0.
I was so excited, I was like,
Interesting.
3.50.
What's the answer?
No, I think I'm
that is
good.
funny that he said it.
0.606 times 30
I like that we say it first.
gives me
So cool.
3, but I'm still at the 10th place. So 331.5
Oh yeah, because
plus
you added.
18.2. So I'm still good to the 10th place, so I should have 4 significant figures in my answer.
Okay.
My B. Sorry guys, that was really lame.
Yeah, significant figures just to make fun out of this easy math, huh? Oh, number 3, what is the
0 for 2.
temperature? Adding and subtracting the significant figures throws everything off. What is the temperature if 545 hertz sound wave has a wavelength of 0.651 meters?
20,000 degrees.
No.
23,000 at least.
Alright, so if I use this equation, what do I end up with? What is that?
Wow, that's like one of the only equations I found that you end up with more significant digits than when you started.
It's not really more though, I mean, it just matters what place value. So, what's my velocity gonna be in this situation if, what is it? I've got,
38.8.
no,
Oh, I don't know.
velocity. You did not
Can I
get
borrow
it
your
wrong. You have
calculator?
to add 300 and something to it,
No. Oh, the velocity.
the velocity.
355.
Baby.
Wait, which one is this? Oh.
We all have attention problems today.
Um,
Sam?
It's
Is that thing still working?
355
Yeah, it's sort of.
Meters per
meters
second.
per second.
355 meters per second. And why do we have 3 significant figures here?
Because it's probably the same thing I did last problem where I forgot about
That's
the
what I thought.
No, I have 3 too, but I don't know why. Is that seriously the end of class?
Yes.
Woo!
Wow.
What are the answers to the rest of
No.
How many? You
I
guys
got
did?
39, and then 3.9, and then 1,400, and
That
then
should be 38.8.
Yeah, number 5 is 1,400 meters.
39.0. And then 259. Okay.
Number 6, I got 259 hertz.
Yes, yes.
I got that too.
Number 7, did y'all do 7?
Yes.
16 meters per second.
16.2
That's the
meters
only-
per
that's the
second
main
towards
part.
you. Next week, don't wear a skirt if you want to.
Man.
Man, Josh, why can't we wear a
And make
skirt now?
sure you don't leave class until I show you real quick how to do the problems for the week after. Because it's not something that you've done before, and you will need a compass.
Do we have class next week?
No, we have.
Yes.
No, we don't.
Yes, you
Not the
do.
week
Do we
after.
have team pack?
that.
Yes,
Wait.
you're the only one who's going to team pack, so you have class.
So we should cancel the whole class.
No.
Wait.
You know what a compass is? The little thingy that you have
Compass
2 points and
Yes.
you make a circle with? You'll need one of those in 2 weeks.
I thought I was like the wilderness and
Yeah.
So we have class
No, we're here.
this week, but not next week.
We have class every
Hey, who's
single
got my
week.
team?
Until spring break,
Yes.
which
When's
is in
spring
April.
break?
Okay, so some of the classes are getting out, but others
Yes.
aren't. Okay, that makes
Like
sense.
government.
Oh, this is still